Hi folks, we are going to talk about IP addressing. IP address are 32-bit number and they are represented as a binary value of 1 or 0. We group these into chunks of 8 bits and then we convert these 8 bits into a decimal value, separating them with a dot or a decimal point so that they are easy to read. So in this example, we have a 32-bit decimal bit binary number. This number is 10101100 and so on. Now saying that address is not easy, remembering that is even more difficult. So for readability, we will take the 32-bit and we will divide into 4 octet. 1, 2, 3, 4 octet. Once we have got it separated into octet, we can take that value and convert it into a decimal number. The way that we do that is by adding up each value that has a 1 with the corresponding value. So the chart would look something like the following: 128, 64, 32, 16, 8, 4, 2, 0. Oh, it shouldn't be 0, it should be 1. Here is a mistake, so please correct it. Here the value should be 1. If we take the first octet, which has value of 10101100, and we add up the places value in each location where the binary value is set to 1, we would be adding 128, 32, 8 and 4, and the result will be 172. Did you get this point? We are adding only those values, those are corresponding to 1. Here 128, here 32, here 8 and here 4, and the resulting is 172. And the same for the next octet, we will get 16, and the same for the next one 128, and for the next one 17. So each octet has a decimal value. We separate that value with the dot, with a decimal point or a dot, a much easier to remember and a much easier number to communicate as opposed to a binary value. So we have an IP address scheme. We allocate IP addressing to our devices. All of the devices that reside on the same network are going to have a portion of the address that is identical. In this example, the engineering subnet is 192.168.1. This is engineering subnet work. Each host has similar network address and the host address. Host address is 1, then this host has 192.168.1, the network portion, and then the host value 2, the host value 3, the host value 4. On the opposite side, we have another network address. The network address is 192.168.2.1. Here you feel the difference. Here is a 2, network 2, here is a network 1. Now each of these network is going to have its address, and that is the 0 address in the host field. So on the engineering subnet, were going to iterate the network address. It would be 192.168.1.0. On the manufacturing network, it would be 192.168.2.0. But how can we tell the difference between the network ID and the host ID? To do so, we need to use an address mask. You cannot differentiate by just seeing it. The color will not be black and red. It will be plain color. So how you can differentiate? An address mask is another 32-bit number that we use as a decoder. When we stack it up against the IP address, any bit in the subnet mask that is turned on or set to 1 counts that corresponding address bit as a network ID. Here you can see network ID and the host. All of the bits that are set to 0 in the subnet mask, those corresponding bits in the IP address are host bits. Therefore, when we convert his binary value to decimal, the 10 portion of the IP address is the network ID, and the 7.4.5 portion of the decimal value of the address is the host side or the host portion of the address. This would make the subnet mask 255.0.0.0 because of the first bit are enabled or the bits that identify the network portion of the IP address. So I will talk about IP address classes in next lecture. See you in next lecture.